Morning everyone. In this video we're going to go through the pre-SAC 1 test. So just 30 multiple choice questions, all from past exams. So I will also talk about the percentage that got it correct. Most of these questions were above, well, I would say 60%. There were some really high percentage ones and a couple very low. So I will point them out. All right, let's make a start. I know I've got the solution there as well, but when I need to, I will talk about what you can do on the calculator, but hopefully just to keep the video a bit shorter, I won't do everything on the calculator. I'll just talk about it. All right, the smallest positive value for tan 2x equals 1. So this was 84%. This was very easy to do on the calculator. It was, actually, I don't know where it's come from on the exam, but I would say it was probably one of the very first questions. You just do solve on your calculator. Make sure your calculator is in radian mode, but you do need to restrict your domain, otherwise you get the general solution. I just restricted it from 0 to pi, so just one period, just to see what I get. Oh, not one period for this one, but for a generic tan graph. And I got just two solutions and I chose the smallest one. All right, so an easy one to do on the calculator, probably take you less than a minute to do. And don't forget you're reading these questions during reading time, so you can actually think, okay, this one's going to be an easy one to do on the calc. All right, question number 2. So this was 74%, got this one correct, so also not too difficult. So we've got the function blah, 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 and the rule is natural log x to the power of 4. So it's a composite function, but it doesn't really matter. We're just deciding how to make it an inverse function. So just sketch it. When you sketch it, let me just show you what it would look like. It goes something like that. So for it to be an inverse function, it has to be 1 to 1. So obviously at the moment it's not 1 to 1. So a is just the lower limit of your domain. So a has to be greater than 0. I just had to pause to think, why couldn't it be less than 0? So the fact it couldn't be less than 0 is because if we had it less than 0, and so let's say it was here, something less than 0, you can still see that it's not a 1-to-1 function because your upper limit is infinity. So it has to be a has to be greater than 0 to make it 1-to-1. All right, question number 3, 86% got this one correct. So again, not a difficult one. It's a composite function. You can put this into your calculator. It's probably just easier not to, because composite functions are just substituting in the inside function to the outside function. So even though g of x was written first, you did have to put it into f of x. So you can see I've got e2, and then wherever you see the x, you're just substituting in this, including the 3. Let me just make sure I circle that. You are substituting in that function. So you can see I've done that there. Put it in brackets so that we don't accidentally mix anything up. Then I just quickly checked, is that solution there? No. So I kept going until it appeared, and there it was, option D. So a very quick one to do also by hand. If you could also do it on your calculator, but would take you longer probably doing it on your calculator. All right, question number 4. So this one here is just rearranging. Again, easy to do by hand. You probably could do that on your calculator. Hold on, let me just think. Oh yeah, we're solving for x. So yeah, you could do that on your calculator. You might have to just rearrange it on your calculator. I just did it by hand. The reason I do it by hand is often on the exam, the options aren't the same as what your calculator is. So doing it by hand just allows you to easily see what those options are, if that makes sense. So your calculator, there's two calculators. So we have the Casio and then there's the TI. So they will usually write the exam so that the options don't advantage one over the other. So often it's not what we see on our calculator. So doing it by hand I think sometimes allows you to see it a bit easier. So it's just solving that equation. And what percentage got that one correct? Let me just check, 78%. So again, not a difficult one. Question 5, the graph of y equals kx minus 3 intersects with the graph y equals y equals x squared plus 8x at 2 distinct points 4. So just simultaneous equations. We've already got y equals and y equals, so we just let the right-hand side equal each other. Then we come up with the quadratic, so we can just use the determinant to decide, just making sure you can see that the coefficient of x, we take out x as a common factor and we get 8 minus k as the coefficient of x. And then I just plugged that into my calculator and solved it. You do get all these multiple solutions. We'd also get this solution on the calculator. I think it was written as 2 root 3 plus 8, so not always writing it the same way. But notice how I eliminated them. I find it sometimes easier just to say, oh, it doesn't look like k equals 11, k equals 5. Or C, it's not in between 5 and 6. So it was either B or D. And I could see there was 2 separate solutions as opposed to having them in the between 2 values. Yep, so not a overly difficult question. That was only 52% got that right though. I wonder, maybe they couldn't read what was on the calculator. I'm not sure, because not a difficult one, and we've done quite a few like that. But we did them at the start of the year or even during transition. All right, question 6 was 68%. So what have we got here? So we want the gradient is negative. So we did this in class after the test. So hopefully now you would get a question like this correct. But you should know when a gradient is negative. So think about your little ant going up here, then it stops at your stationary point, then goes down, stops there and goes back up. You can sketch this on your calculator, very easy to sketch. Find these 2 points, which is x equals -5 and x equals 1/2. You don't have to do it by hand, but you do need to know what section is negative. So -5 to 1/2. All right, question 7. So this one, 95%. So very easy transformations question. You can read it straight from your options. I did it I think on the calculator. Probably didn't need to, because they're not even complicated transformations. So we've got our function. You can define that in your calculator. It's reflected in the x-axis, so that's what that negative is, and then translated 3 units to the right, so it is -3, and then 4 units down, so -4. So I just do define that, and then type that in as it is, and then spits out this, which is beautiful because it was exactly how it's written, and the options didn't have to change it at all. All right, question 8. So this was an 89%, so not another non-difficult one. So with inverses, you just switch your x and y. So I know f of x is written there, but we know that's y. So you can see I've switched them there, and then I just did solve for y on the calc. So typed this in and solved for y on the calculator, which will rearrange it for you. Just make sure you put swap the x and y before you do that. It did spit out this answer here, so I did just have to factorize that quadratic. You can do factor on your calculator, so you can go interactive transformation factor, and sometimes it will and won't factorize it, but it's not a hard one to factorize. And we do know that the range of our original function becomes the domain of our inverse. So the good thing was I only had one that was correct for the inverse. I didn't have to go and check the domain, but if I did have to, so if there were 2 inverse functions that were correct, I would then have to check the domains, but I didn't have to in this case, so that was good. But just make sure you're aware of that. All right, question 9 was a 45%er, so perhaps a difficult one. All right, so we've got the range of this. What I think students would find difficult with this is that they would look at the 2 endpoints, and often, I would say probably 99% of the time, if it's a curve, question like this one here, so sometimes we see a parabola, this one's a sine graph. It's your two endpoints of your domain do not match your range. So you need to sketch it, all right? So it doesn't take long to sketch it. It's tiny when it comes out. So let me just show you. Probably already have it. No, I don't have it here. All right, so I think I used a handheld one. So we've got 2 sine 2x, and do restrict the domain. So to restrict the domain, we go keyboard and then math 3, just restrict it. And we're going from pi on 8, and then that one's included, so we'll include it. And then the pi on 3 is not included. Pi on 3. So restricting the domain is important so we can see what section of the graph we're looking at. All right, so we can see how small it is. So it's important that you can see where the minimum and where the max is. So I can see this is our lower point, which is our pi on 8. So I can just go, oops, sketch, oops, not that one. Soz. Let's just go back again. So function minimum. And there it is. The problem is it does give it to you as a decimal, but we do a lot of work with the square root of 2. So I did recognize that 1.41 is the square root of 2, but if you didn't, let's just have a look at our options. Oh, notice how they're all the square root of 2 anyway, and that point is included. So we could eliminate option A and D, and then your maximum, we can just go analysis, gsolve, and then function max, which is here. And oh, that is 2. Nice, I can read that. So that's why we've got that, and it's included because it's not this endpoint down here, it's actually another point on the graph. So I reckon if we looked at the percentage of students who chose option, I would say E would have been the most popular. I would say that endpoint corresponded to the square root of 3. Not realizing that the max. So those sorts of questions, they appear all the time. So just make sure that you sketch the graph. Usually it's a parabola, but this one was a sine graph. All right, question 10 was 44%. So I don't think these types of questions are difficult. They do take sometimes a little bit time consuming. So we've got this function e to the power of x plus e to the negative x, and we're substituting in 2u. So I've gone ahead and done that. All right. And then I've gone through and done the substitution, just worked my way through. Oh, actually, I did do that, but to save time, notice how the 3 options at the end all have the same starting. So we've all got 3u squared. So in an exam, I'd probably start with that. So we get this, and we get the plus 2 on the end. So we do then have to take away 2 to make it the same. All right, so those sorts of questions are easy, but with methods and probably any other subject, you've just got to do a lot of past exam questions to get familiar with how they ask the questions. All right, moving along. Just having a sip of my tea. All right, another transformations question. This one was 50%. All right, so what did I do? I think I may have defined, yeah. Oh no, I didn't define it. You could define it, but I think I just did it without it. So what are we doing? We're doing a reflection in the x-axis, that's the negative there, followed by a dilation of factor 4 from the y-axis. So that becomes 1 on 4, or x on 4, 1 on 4 times x. So just substituting that in, I did that by hand, but you could use define on your calculator. Just also note that your range changes as well. So when we have a dilation of 4 from the y-axis, it's multiplying that y. No, what am I talking about? Sorry, your x. It's doing both x's. All right, so that's times 4 as well. because it's, yeah, so the dilation from the y changes your x coordinate. So that's why we got 0 times 4 and pi on 2 times 4. So your domain changes as well. But there was only one option of that g of x, so we didn't really have to check the domain anyway. All right, question 12. Oh no, that previous one was 36%. I just read the wrong answer. That was 36%. I wonder what students did. Maybe didn't change the domain. I have no idea. Maybe chose C without the negative there. Don't know. All right. Oh, actually, I know what it would have been. So C, when we've done this negative, multiplies everything. They probably didn't multiply that negative at the end. I would say that's what happened. So notice how I put the whole thing in brackets to remind myself that that negative multiplies the sign and also multiplies the 1. So I reckon C would have been a popular answer. All right, moving on to question 12. So this one was 50%. All right, so another inverse function that we have to make 1 to 1. So drawing the graph is easy then to see how to make it 1 to 1. So you could either have up to from negative infinity to negative half, which was not one of the options. You could have negative a half to 0, which also is not an option, or 0 to infinity, which is also not an option. So it's okay, you don't have to go from those turning points. So then we have to just check. Obviously can't be any real value, so 1/2 is on this side here, so we're going up like that. All right, so as long as it's within that region, I guess, or subset, I should say. 13, so 13, 95%. Yeah, not a hard one to do. You can sketch the graph. When I originally sketched it, I did a parabola and I got it wrong. But just sketch it and then see what type of stationary point it is. You could also find the derivative and then find the second derivative and use that test to see what type of stationary point it is. But they should be an easy question to do and a quick one to do as well. All right, question 14, so 55%. Oh, so this is the general solution, and with this one here, it's kind of, because it doesn't look like how you would see it on your calculator. So that means we just then have to go through each solution or each option and see whether it actually fits our general solution. So I've got the general solution here, what I got from the calculator, and I could see it's not one of those options. So it's definitely not the first one because it's only given us one part of it, not the other. Part B, so we've got the 2n pi plus pi on 4, which brings us into the first quadrant, but the second part brings us into the fourth quadrant. So there's no solution in the fourth quadrant, so it can't be B. I just didn't even... so I skipped C and D because I thought, we'll come back to them. We'll just do a process of elimination. N pi plus pi on 4 would take us into the third quadrant, so it's not that one. So between C and D, so if we think about pi on 2, we're going from this part here. And from there, can go into the first or the second quadrant. So just testing out which of those fit. You can actually substitute in a value for n if you are confused about how to tell, and then just see which one gives you the solutions. It's probably the easiest way. So probably a bit longer to do. You get it on your calculator, realize that it's not, and then have to test it. So a question like that probably takes a bit more time. But when you think about it, when you're doing it and you're thinking about it, it's not overly difficult. It just looks different. All right. It just looks different. All right. Question 15, 53%. So, again, with the function notation, you can see I've just gone through and done each one. I think I accidentally did the first one in blue and then I thought, let's just do them all in different color. So I've just gone through and tested each one. So, asking for which one's not true. These questions are not difficult. They do turn up all the time, just like the previous one with the U in it. But you just got to get familiar with answering them. So question 15, 53%, something like this should have been a lot higher. It's not a difficult question. It just looks more complicated than it needs to be. All right, and you could probably define it, maybe. I never did. Okay, question 16, 79%. So we want, the gradient is negative, so similar to the one we did before. So just looking at the cubic, so you can sketch your graph, get your two turning points and see where it goes down. Okay, so yeah, easy one. Question 17, 74%. We did quite a few of these in class. Yeah, so it is a composite function. So f of x, remember when it's written there, not as a function, like not as x squared or whatever, you just leave it as f of x. So we go through and use the chain rule, but we just leave it as f of x. So I let u equal 1 minus f of x, what was under the square root sign. Went through and found the derivative. Then y is equal to the square root of u, found that, and then put everything together. Or did it all by hand. Yeah, you don't I don't think you can really do it on the calculator. The calculator would help you if you had to find the derivative of something that you couldn't do. But here, because it's all in terms of u and f of x, a bit different. All right, this one here should be 100%er. So 60% of students got this correct on the actual exam. Your period for your tan is just pi over n. It's not 2 pi over n. Remember, tan is friends with sine and cos, but you know, sine and cos are best buddies. Tan, slightly different. So it has a different period. Sorry, you calculated the period differently. So it's pi on whatever n is. So in this case, n is 1/3. So it gives you 3 pi. That is like a 20-second question. If you saw that a question like that on your exam, you should be like, done in 20 seconds. All right, question 19, 83%. Remember, you can also look at your bound book during your reading time. So if you come across a question, you're like, oh, I remember tan slightly different. Maybe I should just check its period. Yep, I'm correct. All right. All right, you can use your bound book during your reading time. Can't use your calculator or your pen, obviously, but you can look at your bound book. All right, 19 was 83%. So another composite function question. You can just see I've gone through there and done that. So 2 times a half just is 1, so that disappears. Then we've got base e to base e, so log base e to e, so they cancel each other out and we're left with 3x. You could probably also put this in your calculator to simplify it. I didn't, but your calculator will probably simplify it for you. And then it just factorized at the end. All right, question 20, 79%. So we've got our function f of x, and then we've got f of 5x. So wherever we see x, we put in 5x. So 2 times 5x gives you 10x. And we've just, see how it's got no number in front of this log, but we've got a 3 here. So I've got to use my log laws to move it over here. So it becomes to the power of 3. So y is equal to 10x to the power of 3, which is 1000x cubed. I think that's an easy question. What was it again? 79%, that's pretty high. All right, 21, 52%. So another composite function. And finding the derivative, so using the chain rule, there's the solution there. We've done quite a few of them. So, yeah, 52%. I think what students have difficulty with is when they've got to do a derivative and they don't have a function there. They could probably do log base e of x squared, but as soon as they see the fx, kind of scares them a little bit. All right, question 22. All right, this was from an NHT exam, so we don't know the percentages for that. So a few coming up are from NHT exams. A tangent line passes through the origin, the x-coordinate, correct a 2 decimal place where the oh, okay. This one was quite hard. So I don't think this one would have been done well. All right, so when you see tangent, so your tangent line is y equals mx plus c. So your gradient is the same as the gradient function, the derivative. All right, so that's the relationship between your tangent and your gradient. So you can see I've substituted that in here for m. And because it goes through the origin, your y-intercept or your value of c is 0. So I just so we wanted to know where it touches. So your tangent touches the original function, which is this log business here on the left-hand side. And that's the tangent function. So we're just solving for x. So probably difficult to see that relationship and then figure out what to do. I think when I was doing that question, I was a little bit like, okay, need to think. Wasn't so straightforward like some of the others. All right, question 23 was also an NHT exam question. And this was a difficult one. This is a composite function where you actually have to have it defined. So I've done my f of x and my g of x and then written the domain and range. I didn't have to do the range of g of x because for it to be defined, I did the range of the inside function has to be a subset of the domain of the outside function. So I didn't really need the range for g of x. And then did my little number line so I could see. So there's my range of f of x going from -4 to 8, and then my domain of g from -√3 to √3. So I had to restrict my range of f of x. And then because the range is dependent on the domain, you can see I just got my function. So here's f of x, the 3x minus 1, and let it equal my 2 endpoints for my y, and got, I know it's a bit squishy there, so those 2 values. So yeah, though I would say with composite functions, that's probably a difficult thing. So making sure you've got an example of that and annotate it as well, why you've done everything. All right, don't just have the working out because, you know, your SAC is coming up, but if you don't see a question like this until your exam, then like how are you going to understand all that? What did you do here? So make sure you actually write what you do. Question 24 was also a NHT exam question. So this is the only time you will see angles in degrees. So you've got to make sure, if you're using your calculator, put it in degrees. So I did. So tan of 135 is equal to -1, which is north. So that means the gradient is equal to -1, which we've got here. Actually, I didn't go back and check this. So I got, so we got the derivative of our function. So we can see that here. Oh no, sorry, that's not the derivative. That's the circle. So they've got the circle here, but I changed it to be y equals so I could take the derivative. But we do have the plus and minus because you have the top of the circle and the bottom of the circle. Then taking the derivative of just the positive because we're just looking at the positive part. So I took the derivative of that and let it equal -1. And when I did that, I got √2 on 2, which is the same as 1 on √2, but I didn't go back and check why it was negative, but it was only one option like that. So, don't know why I didn't double check that, unless I put my, yeah, I kind of feel like I did everything correct and I was meant to go back and check, but just conscious of time that, yeah, I'm not going to pause now and check because otherwise it's going to take forever. All right, question 25, another NHT exam. So you've got your transformation written as a function notation. So I just looked at the transformation first. So it went to the right 1. So I looked at any key points where it went across. So I could eliminate A, B, and E. And then I looked at the reflection. So it has been reflected along the y-axis, so that gives you D. So you could have looked at the reflection first as well. All right, question 26 was 69%. So we've got the product function f of x times g of x is equal to this. So we've got f of x, and then we've got the product function. So f of x is e to the power of x minus 1 times g of x is equal to this. So I'm just set up an equation and solved for g of x. Even though, you know, we're used to solving equations for x, but we're solving an equation for a function. So I just brought the this e to the power of x minus 1 over to the right-hand side, and just had to do some tidying up, which I think I did with the support of a calculator. All right, question 27, 29%. This one was probably the most difficult one on the test. So just trying to draw it as best as I could here. So I've got a polynomial, the number of tangents to this curve that passed through the x-intercept. So I started with sketching it, and then I thought, well, how can, and then, yeah, so obviously I sketched it on the screen. And then I thought, well, how can I do my tangents? So there's one going up here. All right, and then, so just at the stationary points, and this one here, and then this one here, so 3. And they can only go through that x-intercept. So obviously we would have infinite. It's not the x-axis, it's the x-intercept. So yeah, just the 3. So the one actually at the x-intercept, and the other 2 stationary points. Actually, yeah, all good. All right, question 28, 62%. Which of the following functions? Oh, okay, so you can just, oh, how did I do this one? Oh, you can sketch them, but you can also just find the derivative at 0. I think that's what I did. So I just went in, because it's at the point 0, 0. So just going to main, you can go to interactive, calculation, differentiate, put your expression in, and then, whoops, differentiation at a value, and put 0 here. So, whoops. So if I put the correct answer in, so x to the power, just put it in brackets, 4/3, and you can see you get 0. So if we did anything else, I'll just show you with 1/3, undefined, right? Because it's not a stationary point. If it was a stationary point, it's also a horizontal tangent. Ooh! All right, 2 to go. The set of values of p for which has 3 distinct solutions. Oh, so for this one, I might show you on the calculator. So get rid of that. So just typing it in, x cubed minus, and then p times x. Make sure you put a times in between, plus 2. And we don't have to worry about the equals 0. So instead of pressing the first graphing, pressing the second one. And yeah, we just want to add in a parameter. That warning sign wouldn't come up. It'll ask it, would you like to add a slider? All right. Because my window is how it is, we can just go to quick and just go standard, see if that helps. Beautiful. And then you can just move your slider. All right, and it helps you see what's happening. And because there's options there, you can see what's happening with 3. All right, and then anything above 3 is going to give it 3 solutions. So that was an NHT exam, so I don't know that one, but yeah, whenever you see that, using sliders is good. All right, and last one. So this is just your inverse. So given the graph now, it's got 2 points, although they're not the exact points, and not exactly 4, 4, but it does help. So when your inverse does reflect over the line y equals, actually it probably should be going through, if that's 4, 4, should be going through that point, reflects over that line. So it kind of would go, oh, I'm not going to draw it very well, but it'll go something like that. So I just wanted to make sure it had that 4, 4. So I looked for that first, and then I just basically went with the shape. So I think I eliminated, so I looked for the 4, 4, and then the -3, because with your inverse, remember the coordinate swap. So 4 and 4 switch still gives you 4 and 4, but the -1, -3 will become -3, -1 on your inverse, and then looking for the shape. So the only answer was C. All right, guys.